Hi. Okay, the mic's working. So this is a presentation on how effective platform engineering enables sustainability. Yeah, so I'm Luc Burnip. I work at EY as a senior consultant within the technology consulting space. And we're looking at how we can deliver large-scale projects to customers with sustainability at the heart of them. And that's something we're trying to build this presentation around. Before we dive into the bigger picture of sustainable software and IT, I want to set the context with some background on sustainability more broadly and how IT and technology in the industry fits into the much bigger picture. So this graph on the slide shows that global temperatures have increased by over 1.2 degrees. We know that for every ton of CO2 emitted, there's an increase in global warming, and the more tons of CO2 emitted, the more the planet warms. If we want to stop global warming, we have to stop emitting. The sooner we stop emitting, the sooner we can start lowering this graph from such an alarming sort of exponential growth on the right to sort of more reasonable temperatures. Advances in science have allowed us to work out how much CO2 can be emitted before we reach 1.5 to 2 degrees global warming. Now, 1.5 to 2 degrees is when sort of there's detrimental impacts on the planet, ecosystems start to break down, human life starts, human life as we know it starts to change, flooding, droughts, heat waves, those sort of things. And we're currently at 1.2 degrees global warming. Research suggests that we can hit around 3,600 billion tons of CO2 emitted and stay below 2 degrees global warming. However, we've already emitted around 2,000 billion tons of CO2. Now, this only accounts for CO2, not other gases such as nitrous oxide, and this is what's called, these calculations are what sort of form the basis of what's called a carbon budget. Science suggests that we should limit our remaining carbon budget to a total of 850 billion tons. Of CO2 left, and this would give us a 66% chance of staying below 2 degrees. Now, 66% chance is good, but when you're betting the livelihood of the planet and ourselves on it, it's not really great. We currently emit 36 billion tons of CO2 a year. So if you divide your 850 by 36, this gives us approximately 24 years at the current rate before we start to face detrimental effects. But we're not at the current rate, as you can see on the graph. We keep increasing our yearly emissions year on year. And most of these emissions are coming from the industrial age and the technology sector. So the technology sector itself is supposed to hit 8% of global emissions, total global emissions emitted by 2030. So the technology sector is starting to have impacts that spill over into the real world. And when we look at how we need to start to look at how we build sustainability to how we build and operate crucial services. Particularly if you start to think a lot of these large-scale IT projects are in service for 10 to 15 years. If we've only got 24 years to make a difference, really, and you've got a new project starting now that will be in service for 10 years, that's really something that we need to start, putting at the heart of that project and looking at and making some serious design decisions around how we build for sustainability. There's a Financial Times report that shows that they've started to put a ban on building new homes in West London. This is because they've prioritised data centre building in that region to support the financial services hub of London. Each data centre uses the equivalent of around 10,000 homes worth of electricity and around a city's worth of water usage to cool it. There's also a BBC report that shows that data centres soon will consume 25% of all electricity in Ireland. And right now, the internet itself is responsible for 4% of global emissions, and this is supposed to grow to 8% by 2030. I think to put this into perspective, the airline industry and flights contribute to 3% of global emissions. Everyone seems to point the finger at people flying to places and going on holiday, but no one seems to point the finger at technology or technologists and sort of the systems we do. Obviously, it's a lot harder to stop someone flying than it is to stop turning off the internet, but I think it just puts things into perspective a little bit. So when I think we start to look at accountability, I think it's us that, as technologists, that have to play a vital role here. It isn't just the public cloud providers and it's their problem to solve, but it's also us as developers, architects, and technology practitioners that have to look more and more into this sort of thing. Public cloud does provide a great engine, as we'll discuss in the following slides. But if we put our code and our infrastructure in there and run it in second gear all the time, it will never be as efficient as if we make best use of these services and almost run it in sixth gear. Then we'll have a sort of flywheel effect as we start to design more effectively for sustainability. I think it's also key to mention the UN sustainability goals here. More specifically, these ones I think have a very direct impact to sustainable technology and what we do. So this is sort of looking at clean energy, supporting good working jobs and economic growth, innovation and technology innovation and strategy, sustainable cities, how do we design cities more to work around sustainability more often, and how can we build, how can we use technology and data to support this? Responsible consumption and production, so here we start to look at, are we using the best use of our IT resources? And then finally, climate action. I think these all have a direct impact on what we can start to do to reduce our climate impact. Next, if we look at the state of the landscape, originally I did have a Wardley map here, but I think Simon's coming later today and I was quite embarrassed about putting it on the screen, to be honest. So I've changed it into some nice bubbles. Why should companies care about sustainability and why is it important? I'd say that it's almost, we can't afford to not think about sustainability and climate change factors now. I believe that this is bigger than business and it's bigger than any single team or organization within a company. Because if we get this wrong, there's really no company or business to go back to in a few years. There's a number of factors that are at play here. Economic and geopolitical uncertainty. Climate change only adds to this, it will never take away from this. Increase in stakeholder expectations, be it clients, customers, shareholders, and even prospective and new employees. 70% of new employees consider ESG factors when they're joining a company. And 84% of consumers start to consider sustainability when making a big purchase. More businesses want to know how we can respond positively to climate change. And businesses need to maintain consumer and customer trust. There's also increased regulatory pressures around net zero and climate commitments. And shareholder and investments, 90% of investors place an importance on ESG strategy before they start to put a big investment into a new company. So when we look at technologies, what could we use and how can we get there? This may include looking at things such as moving towards serverless so that we can focus less on the underlying infrastructure and more consume things as a service and put our best people onto focusing on building proper business outcomes that meet the sort of customer requirement rather than focusing on the underlying infrastructure and almost designing at a higher level service around more designing for sustainability more intentionally. We're starting to look at where we can look forward and not look backwards. If we take a step back and we can't intentionally design for serverless almost, do we start to look at containerization, virtualization, and bare metal as a last result? Because of this, I think building up a competency, not just at the organizational level, but also within the technology team itself is vital to remain competitive in this industry. And it's almost too late already, if you like. Next, as this is a platform engineering talk, I wanted to define what we view a platform as, what we view a platform is, because depending on who you ask or your background, your view might be slightly different. We think that a platform isn't just about technology, it's also how you organize and deliver to enable flow within teams. We embed the core principles of a next generation leadership into our organization, into our team methodologies to enable platform delivery. This includes leaderless leadership, non-hierarchical structures, and an outcome-driven culture motivated by customer and societal outcomes. From a more technology-centric point of view, a platform enables the provision and management of resources to run interoperable services that are typically broken down into a set of modular capabilities to realize direct business benefits. These can be consumed directly or exposed through APIs that enable other teams to develop new or updated capabilities. We also view our platform as a product, not to the end customer directly, but to our development teams that run business services on our platforms. We think that platforms are something that enables the standardized delivery of services in a method that attracts ongoing investment over time. This in turn allows the platform to become quite a rapid change agent for business through the exchange and iteration of business capabilities And this is accelerated through and almost enables the implementation of emerging capabilities as we build out a platform due to the ability to reuse common components through things such as reusable architecture patterns and standardized APIs. However, a platform isn't just about technology, it's also how we organize and deliver flow between teams. So yeah, it's not just a technology-centric point of view, but it's broader. And I think there's been a great talk earlier about what platform delivery is as more of a deep dive into that. Next, I wanted to talk about how platform engineering enables sustainable software delivery. So what we started to do here is we started to embed sustainable principles onto a DevOps loop. And this is obviously supported by the previous slide and is supported by effective platform engineering. And this is baked into how we run and manage a platform. We wanted sustainability to be viewed as familiar to existing teams, so it didn't have a steep learning curve. We wanted it to be emergent, so over time we can start to iterate and improve on it as new technologies arise. And we wanted it to be an iterative process. We didn't want to build a whole project around sustainability, because a lot of projects you inherit already have some sort of technology artifacts built up. So we wanted to sort of pick something where we didn't have to boil the ocean, and we can focus on building one component specifically for sustainability and then work towards that more broadly and share it within the wider organization. When viewed for a platform engineering lens at scale, this gives us a framework to effectively tweak a large-scale system on the fly and realize sustainability benefits over time. If we start to look at a few of these sort of sectors of this DevOps loop, within the design and develop stage, we tried to build standard architecture artifacts with sustainability built into the whole sort of process and the whole process of architecting a system. We then try and share these across teams and across accounts so that we have a standard way of doing things that can be modularized and sort of industrialized over time. We also hold regular third-party cloud architecture reviews with the public cloud providers. These are things such as AWS's well-architected framework for sustainability. I know Microsoft and Google have recently come out with similar offerings. And this is really so that we have the best use of cloud-native features from conception. So we're consuming where we can consume and only custom building where we have to custom build, because a lot of people will consume an AWS service directly, so they're in a better position to directly build that for sustainability rather than us using a custom-built application that only we are responsible for building for sustainability. We also start in this phase, we also look at things such as the shared responsibility model. So what are the cloud providers responsible for, such as providing clean power, providing well-built data centers that are designed for sustainability, and then what are we responsible for? The infrastructure we provision, the size of compute instances, and those sort of things, and actually the code that we run in those instances. We also look at software development principles. Research shows that imperative languages such as C require significantly less energy than object-oriented languages like Java. But scripting languages such as Python require even more energy still. And we do factor this into our tooling choice, but we also balance this with the fact that if we've got a Java team, we will use the Java team. And also if the customer has an application that needs to be built in one type of language, obviously we'll try to use that. And then obviously we also start to look at the bigger picture, such as how well will these languages integrate with a microservices type architecture. We also look at code quality monitoring tools. How can we embed code quality, carbon sort of reporting and carbon sort of checking into the code that we push into production? And how can we monitor this within a CI/CD pipeline? Some of the tooling here is things such as the Green Software Foundation that the previous talk talked about. They're starting to look at how you can monitor the carbon intensity across a whole CI/CD pipeline. Next, we look at provision. Where are we actually running this application? What are the sustainability credentials of the suppliers we decide to partner with? And how is this application orchestrated? Is it serverless-based? Is it not serverless-based? Is it bare metal-based? In some respects, serverless will run things greener. In other respects, it actually doesn't, because if an application is running 24/7, it's usually better to run that as a container rather than as a serverless function. Optimization and measure. How can we right-size our compute so we're not over-provisioning compute resources for the applications we're looking at? And also, how can we embed platform observability to provide efficiency metrics as well as resiliency metrics? And then how can we inform these reportings that we do to almost do another loop of the DevOps loop we've got here and give these metrics back to our development teams, almost like we're shifting left to observability-driven design for sustainability. So we're providing our developers with what the real sustainability impact that code and those modules are having in production. And what we're trying to almost do here is we want to get to a state where we're running simulations on our infrastructure, a bit like chaos engineering, but around sustainability. Finally, if we look at reporting and adapt, we look at cloud cost optimization through a FinOps lens. We look at how we can support an emergent architecture approach where over time, as new technologies start to arise, things like ARM-based processors, which much more performance per watt, we can embed those into how we build a platform and standardize those as sort of the best practices for what we use. Here, we also view sustainability as a cost optimization. We found when we've designed intentionally for sustainability, we've actually also reduced our cloud operational expenditure. So depending on the client requirements, if they're really sustainability conscious, well, we can almost drive towards sustainability. But if they're really cost conscious, we can drive towards cost and say, we will reduce your carbon impact also by designing around a cost conscious model. And then finally, we also embed application portfolio management techniques into our reporting. And then here we can simplify the next iteration of the DevOps loop, targeting different architectures and different business services through an approach around simplicity, modernization, and transforming. And then this can be given to our teams as sort of a reporting package to inform the next level of sprint planning and the next service that we design to build. If we then look at platform engineering for sustainability, in the middle we've got a lot of what most typical cloud-native app platforms would deliver as part of any sort of deliverable. And actually, a lot of what you've already got can be viewed through a sustainability lens if you decide to do that. So it's what we're trying to look at here is how can we as platform engineers help the sustainability agenda? Look at what we've already delivered and how can we view this from a sustainability lens. Look at things such as your Mac architecture principles or composable architectures. And if we look at some of the ones on the screen here, we can reposition these to view from a sustainability lens. Serverless functions, these support sleep and wake on demand. This results in lower power consumption, and it's also easier to maintain at scale because teams can focus on higher value services. Platform observability, comprehensive end-to-end platform monitoring enables us to see how a service is performing from the back end to the front end to the user experience at all stages of the user journey. And then we can look at how we can intentionally design for sustainability and the knock-on effects that has at other ends of the system. API optimization. How often are APIs called? Are they called every second or are they called every minute? And are they unnecessarily called or are they necessarily called? And how can we build an event bus architecture around this and design that for sustainability so everything feeds into a well-designed sustainability pipe? Finally, we've got network architecture optimization. Are we making best use of cloud-native services? In a previous project we've worked on, we had the logging stored in Ireland and the services running in London. Now, there was gigabytes of logging being transmitted every minute to Ireland. Now, what we had there was two cloud services working for the same project, but in different areas of the country, and gigabytes of data being transmitted every minute. So almost what we tried to do was consolidate those into one region, because as you're traveling data from London to Ireland, you're going through a lot of middle data centers that are using a lot of energy in the middle. So by consolidating that using services such as Azure Express Route and AWS Private Link, we're able to consolidate these into one place and mitigate this unnecessary data travel around the country and unnecessary energy usage. We also saved cost and improved our security posture by doing this. Oh, sorry. Yeah. Next, how can we create a sustainable platform engineering community? So we said previously that it isn't just about the technology you deliver, but it's how you enable flow. So the first area we look at is almost how can we build a culture that fosters and supports sustainability and has sustainability as a value within the organization. Now, this is both important at a corporate view. Does your company take sustainability seriously and isn't it aligned with your values? But it's also a grassroots view and a delivery team view. Do you have sustainability? Are people aware of sustainability within your delivery teams? And do they consider it when they're starting to build infrastructure and technology platforms? So when we're building a sustainable technology delivery culture, it's important to have the following. View sustainability as a cost optimization technique. Some customers will be sustainability sensitive, others are cost sensitive. Look at how you can embed this within a FinOps framework to look at how you view sustainability as cost over time and how you can reduce it to use it to help reduce your cloud cost. Work closely with technology partners. By working together and collaborating with others, we're able to deliver more customer-centric solutions within a shorter time frame and iterate on top of this. We've also been able to collaborate with technology partners in the past and look at existing tooling we use and say, could we start to look at that from a more sustainability-centric point of view? And in some cases, they haven't actually thought of that themselves. But because we've approached them, they've almost said, we'll try and help build that together almost. And it's sort of a win-win for both parties. Simplicity is key and it does support sustainability. We found that from a systems architecture viewpoint, but also from a DevOps and delivery velocity viewpoint and governance viewpoint, systems that are well designed are inherently easy to modify over time and can be easily adhered to best practices around sustainable technology. And it also helps us manage technical debt, toil, and helps us build carbon accounting flags in the architecture more easily because they're more easy to understand and there's less to go wrong. Focus on sustainable community, continuous improvement and learning. Look at how you can embrace a sustainable culture within your DevOps delivery model and embrace short-term iterative development as discussed on the previous slide, but with long-term strategy to embrace failure and learning. And then design an architect for sustainability throughout the entire system lifecycle. The whole end-to-end system technology platform should be built around sustainability from conception to decommission and migration. We should see how we can almost flag for sustainability at each of those points and how we can make sure that we're not unnecessarily wasting hardware or physical resources, how things are recycled at the end of it, and almost have a rent reuse first mindset when we're building these things. And then finally, customers and strategy. How we focused on building a culture that aligns with the customer goals, but also with our own internal team's goals around and making sure that we don't conflict sustainability goals within both of these areas. Next, I want to just talk about some example tooling you could use to enable sustainability. Now, this is a mix of closed and open source tools, and it's stuff we've used in the past. So it's not a sort of one size fits all. It's just what you could generally use and what's been delivered previously. We're looking at iterative and incremental here. We're not boiling the ocean at once. We've stuck with most of the services here we actually already had, and we've leveraged our partners to see how we can look and build these from a more sustainability-centric point of view. And it's based on the principles that lower carbon solutions cost less to run, are likely to be better quality because they're architected intentionally and more simply, and also give a strong business case for emergent and re-architecting over time if we have a more monolithic application that we want to move to a more microservices-based approach. We can say that this will reduce your cloud costs, but it will also aim to reduce your carbon emissions. An example here is Spot by NetApp. So this right-sizes workloads in real time. It looks at sort of the application you're running and it right-sizes the cloud instance you've got provisioned in real time to make sure it fits that workload most appropriately. And it makes sure that you're not overspending on cloud resources. Another example is Grafana. This can be used to build sustainability-focused metrics using all of the tooling throughout there to feed into a Grafana-based dashboard. And we build these for different personas. So we might have business stakeholders and delivery teams. They might have different viewpoints for how they can look at things through a sustainability lens. And then finally, we're looking at governance to support sustainability. Here we're looking at almost what do business and technology drivers and what can the organization do to support sustainability. We split it into business and technology, and we've previously laid this over the TOGAF framework to make sure that enterprise architects can support sustainability. We've also aligned sustainability targets to all areas of the ADM in areas such as business data, application, and technology. A few benefits to call out. So data lifecycle and architecture. A data retention policy is in place to delete unnecessary data. A technology is used to reduce the resources and the carbon footprint of what we use. And a managed service is used in favor of self-hosted solutions to leverage velocity and reduce toil and reduce the carbon footprint of our IT estate. Aligning SLAs, for example, the service must be up 99% of time within working hours. Does that mean the full service has to be up to support 10,000 users worth of capacity? Or is it just the logging screen that has to be up 99% of time? And then can the rest of the service scale out as needed? So it's sort of, we're trying to look at SLAs and make sure that they support sustainability and are not written in a way that detracts from it where possible. And then connected innovation. We're constantly looking at new technologies to realize sustainability gains, such as advances in CPUs, increased data center PUE ratings, and looking at IoT and digital twins, and looking at how we can feed that into how we build more sustainability-centric solutions. So I'd just like to just run through some key takeaways here. So from a carbon point of view, we'd like to build applications that are carbon efficient, and using as little carbon as possible. We also want to run these on electricity that's in the greenest possible data centers and using, ideally, renewable power. There's been some great talks previously where they talk about demand shifting to data centers with lower carbon regions, and there's things such as the Green Software Foundation and electricity maps that have views that help you sort of pick which cloud regions to run things in. Embodied carbon, build applications that are hardware efficient and run on lower power hardware. Energy proportionality, maximize the energy efficiency of the hardware you're running on through building it in almost facilities that support well-designed cooling and things such as that. And then networking, reduce the amount of data and distance it travels on the network. We did this with the logging example we discussed previously. And then demand shaping, can you either run big workloads such as a payroll job or an engineering rendering job at a time when you've not got much strain on the electricity grid, so you're more likely to use renewable power, or can you use it can you run that in a region of the world that's more likely to have renewable power? And then management and optimization, can you reduce, focus on step-by-step optimizations that increase overall efficiency? We tried to explain this through the DevOps loop. So thank you for listening. Sorry if I went on a little bit. I'd just like to say as well, there's Natalie, Mel, and Nolan weren't here today, but they've helped me build the sustainable DevOps loop, and I think it's fair that they get some recognition too. So thank you.
Thanks, Luke. Sobering stuff with the statistics at the beginning,
thanks.
But equally heartening to know that there's lots of thought being put into how we might solve this stuff. Any questions? Guess we're all too hungry for questions.
That's good.
Sorry, can I ask a quick one?
Of course. You've already got the mic.
Yeah, I guess in your day job as a consultant, do you see companies proactively going to you and your company looking for ways to embed sustainability in the actual DevOps process?
So I think it's quite interesting at the moment. If you start to look at if you search for sustainable technology more broadly, you get a lot of information from things such as AWS, Microsoft Azure, Google Cloud, saying how green their data centers are in terms of how they've built them. They're even starting to use things such as low carbon cement now. Like they've really put a lot of thought into that. I don't think there's been a lot of thought put into the next step, which is what do you build as technologists to put in that data center? And that's kind of what we tried to talk about here, if you like. So when we speak with customers, yes, they want to know how they can run their facilities more greenly if they're in a hybrid cloud or private cloud. But what we then talk about is, well, actually, is that built in the first place to support sustainable principles, such as the ones we had on the previous slide, right? And actually, that's still quite a new area. I think things, obviously, people such as the Green Software Foundation do a lot better job than me at explaining those things. But it hasn't been pushed through to customers yet in the same way that actually running it on green energy has. But I do think in the next 5 to 10 years, it will be the sort of thing people start to think of more broadly. Is actually, we're running it in a good place, but are we running it well, almost, if you like? And I think that's as much of a people problem as well as a technology problem, because it's looking at how your teams view, sustainability, as well as it is how you build for sustainability, if that makes sense.
Hi, Luc. Just
Hiya.
a quick question. So, what would you recommend for like a company as a first step if they want to make their cloud solutions more sustainable?
Yeah, so I think the first step is actually measure what you've got as a baseline, because you can't really, how can we know what we're working with until we've measured it at first? That can either be done from an economic point of view, using a FinOps sort of approach and a cloud expenditure point of view, but also public cloud providers are now starting to look at, they've actually got sustainability dashboards where you can look at that. Now, those might not include things such as Scope 3 emissions, I know 2 of the cloud providers don't currently offer that, but it gives you something to work against, if you like. So it's almost better than nothing. You can't measure you can't improve on what you can't measure is kind of a way, I guess, of viewing it.
Thanks.
Maybe I have one more question. So,
Hi.
I think that maybe one more thing that can be done is to press on the hardware producers to put more, let's say, thought into how their products consume the power, and basically instead of putting more and more power to do the floating point computations, etc., just think about, well, do we need all this power how often do we need it compared to how often the processor or any other accelerator has to remain idle and not crunch so much?
No, you're right. There was something I read, it was a Google paper on machine learning. I think it said for every percentage of above 80% that a model's trained, it uses double the amount of power that it got to be 80% trained. And it's almost like, just because you can get it to 100% trained on a data set, does it actually mean it has to be 100%, or is 80% good enough? Obviously, it depends on the use case and those sort of things, but almost that's not even a question people ask. They just want it 100% trained because it can. You know what I mean?
And
such as that.
That's also what you said about the SLAs that, well, for example, do we need to be running at 100% capacity all the time as network provider, for example?
And sometimes it's just asking the question in a different point of view, such as, is the whole service 100% of the time, or is it just the log on screen? You know what I mean? And sometimes that question doesn't even get asked because what we were trying to say in those previous slides is it's just looking at things through a different lens, right? It's like you have your TOGAF things, your business data, app and technology. They're all looking at the same problem, just through different lenses, and sustainability should be another lens that's looked at, right?
You're right. Thanks.
Okay, any more questions? I think not. Let's have another round of applause for Luc.
Thank you.